about parabolas. So parabolas are tricky. They can go 4 different ways. So we're moving into, we suddenly jumped to chapter 10. I don't know if you noticed, we were in 5, we're in 10 now. So I'm just covering what the state makes me cover. That's all I'm doing, is what the state says we will cover to make this class transfer to the universities in the United States. So, or any university in the world, I think. So, what do we have to cover? We have to cover what are called conic sections: parabola, ellipse, and hyperbola. So I'm doing little symbols up here. So parabola is a U shape, and you're used to that, right? Like y equals x squared. You know, that's a parabola. It's a U shape, right? But now we can turn them all different ways. They can go up, they can go down, they can go right, and they can go left. So we're making it a little more complex. We're letting the parabolas go 4 different directions, and we're also going to find more specific. We're also going to move them off the origin. You know, they're going to be sitting somewhere weird. We're also going to find the focus points. They have a focus inside the middle of them. We're going to find where that is. So we're just going to do more than we've ever done before with parabolas, get more specific. So let me lay out the big plan. So on your 3x5 card, for sure, what you're going to want to have is the big plan. That's why I have room. Here, I'll come down here, where I have room to draw. In fact, let me just go to a fresh screen. Yeah, I think I better. So I'll come back to the question, but for parabolas, let me just give you the game plan. The tricky part with parabolas, they can go 4 different directions. They're the hardest. 10.2 is the hardest. 10.3 and 10.4 are a little easier. So parabolas can go 4 ways. They can go up, down, right, and left. And the equations are different depending on which way they go. It's all about, the direction is determined by the first power letter, not the second power letter. So this one is going what? Positive y direction. This one's going negative y direction. This one's going positive x direction. That one's going negative x direction, isn't it? That'll be the first power letter. So in other words, this is x squared is positive 4ay for that one. This one is x squared is minus 4ay. See how the first power letter, positive y, first power letter, negative y. So don't worry about the second power letter. Don't worry about the x squared. It's the first power letter that tells you the direction story. You tracking with me? Everybody see what I'm saying? The unique characteristic of a parabola, what's special about him compared to the other two, is he always has 1 letter squared, 1 letter first power. He always has 1 letter squared, 1 letter first power. Over here, it's going to be y squared is positive 4ax, and y squared is minus 4ax. Everybody see that? So positive x, negative x, negative x, positive x. Everybody see what I'm talking about? So again, the unique, the special characteristic of a parabola is he has 1 letter squared, 1 letter not. All the other ones, the ones we'll do next week, they have both letters squared. Hyperbolas, ellipses, they have x's squared and y's squared, everybody's squared. But parabolas, 1 squared, 1 not, and the one that's not tells you the direction the thing's going. If you have a positive y, it's going up. If you have a negative y to the first power, it's going down. If you have a positive x to the first power, it's going right. You have a negative x to the first power, it's going left. The first power letter tells you the direction. Bless you. That's like half the battle right there, is knowing and recognizing that. Put it on your 3x5 card, but even memorizing it's even better. You just know it immediately. Come back over here now. So look at this question. We can probably eliminate some of the possibilities right away. This thing's going up, isn't it? So it's positive y to the first power. You with me? Because it's going up. Positive y to the first. So it's not this, it's not this.
Sorry, not A and B.
So it's either C or D. You good so far?
Then it's D.
Because those have positive y to the first power, don't they? And this thing's going up, positive y to the first power.
Oh.
Good. Now, which one of those is it? Is it x squared is 25y, or is it x squared is 1/25 y?
Just
plug in the point. Totally. Just plug in the point. Yeah, just take the point, which is x 1, y 1/25. So you put in x1 and y 1/25. Does it work for that one? Yeah. 1 equals 1. That's the one. Must not work for the other one. We good?
Why would it would trick us?
All right, I'll move on if you're okay. All right, so which of those is it? Well, first off, look at the direction. Let's let the direction help us. I know it's not sitting at the origin, but it doesn't matter. Which direction is it going? Positive x, positive y, which positive x or y or negative x or y? Yeah, it's going in the negative x direction, isn't it? Left. It's headed left. Isn't that the negative x direction? So we're thinking it's y squared is minus 4ax. I mean, they don't have an a. The a is going to end up being some number, but that's the general look of the equation. You with me on that? Negative x to the first power. So it's got to be, so it's no way on that one because that one doesn't have a negative. No way on this one because it has negative y to the first power. No way on this one, that's y. No way, boy, this is working great. That one doesn't have negative. It's got to have negative and it's got to have x. So no way here, no way here. It's one of, wow, we're already down to two options, G and H, right? They both have a negative and an x to the first. Negative and an x to the first, huh? It's either G or H. That was helpful. So which of those is it? What am I going to do? Plug in the point. Yeah, plug in the point. So let me take G. I'll take G here and say y minus 5 squared. Oops, getting a little scribbly in my 5s. Y minus 5 squared is minus 4, x minus 1. So put in the point x, y, negative 1, negative 5. So put in negative 1 for x, negative 5 for y. Does that work? That'd be negative 10 squared is negative 4 times negative 2. I don't think so. 100 equals 8. No, it's not G. Must be H. You could plug it in. I'm sure it would work. If you put in, what, negative 1 for x? Yeah, that'd be 0. And negative 5 for y. Yeah, that'd be 0 equals 0. That works. See how negative 1 for x, negative 5 for y does work? 0 equals 0. So G it is. Or H. I mean, H it is.
Can you just look at it and just go the opposite of those points? That point there?
Yes. Oh, good, Barbara. I should be saying that. Yeah, you should be teaching the class. Yeah, exactly right. Well said. I don't know why I didn't think to say that. Yeah, it's always going to be that way. The center. Whenever we move these, all the rest of the sections. Whenever you move, and you've learned that, huh? Whenever you move something around, the what's in the parentheses is always the opposite. Exactly. So the minus 1 minus 5 will be x plus 1, x plus 5. That'll always be the case, not just for the parabola, but next week for the ellipse, hyperbola. Correct. Always the opposite of the center, and that is the center, isn't it? Yeah, good. That's a good observation. They will always give you when they give you the center, it's always opposite in the parentheses. So let me write that. So the center, minus 1, minus 5, opposite signs in the parentheses in the equation. Always. For all these shapes. So we're expecting x plus 1, because that's the x, and y plus 5 when we look at the equation. And you're right. That's the other easy way we could have recognized that. Good.
H and K.
That's the HK thing. Yeah, the way the book writes it out, the way they write it, they say x minus, they say the center here. Let me show you how to, a lot of trick in math classes is reading the lingo. It's hard. Center is HK. How the book, if you click show me an example, what they'll say is they'll go, the center of all these shapes is HK, and in the equation we have x minus h and y minus k. Do you realize they're saying the same thing I just said, but they're saying it in kind of funny talk? When they say the center is HK, they mean whatever that is, then opposite of that in the parentheses. See, negative h means opposite of h. That's the new thought you need to think clearly if you want to keep moving up the line in math. Because earlier, back in your algebra days, everybody, back when I was an algebra student as well, I just thought a minus sign always means minus. But not so, not when it's on a letter, right? Because that h itself could be negative 3, then this is actually x plus 3, isn't it? So instead of thinking a minus sign on a letter always means minus, think a minus sign on a letter always means opposite. Opposite. So when you see x minus h, you go, oh, opposite of h. Yeah, that's what they're saying when they give you that formula. Opposite of k. Right, that's what they're saying. So opposite of hk. That's what they're saying. Exactly right. First. All right, try that one. Think about the direction. It's going up, right? And then think about the center.
Is it
got to be opposite, opposite, right? So we're looking for x minus 3 and y minus 5, because that's positive 3, positive 5. The equation with the parentheses always have opposite. So no way, no way, no way, no way. So we got rid of those because they don't have minus, minus. And now what about the direction? It's going up, so that's positive y to the first power. Got a positive y to the first power. Which one of those 4 that remain have positive y to the first power?
G or H.
Is it only h, or am I missing something? Positive 4y. He has x. I'm talking first power.
Yeah.
It's the first power there. He has x to the first power, no way. He has x to the first power, no way. He has y, but it's negative. So only h has positive y to the first power. Good?
Oh, just H.
Answer's always h. Last two. Good on that? Questions? Okay, so try that one. Think about the direction. So that one's centered at the origin, so we don't have any parenthesis minus. I don't know if you noticed that. Those last two were moved, and it had a center other than 0, 0. Right? Let me help with that. See how this one has a center? The center's not here at the origin. So if the center is somewhere other than 0, 0, that's when you get the x minus whatever and y minus whatever in the parentheses in the equation. But if the thing is centered at the origin, then you don't have any of that. I mean, if you want, it's y minus 0 squared and x minus 0. So it's just y and it's just x. You get me? You tracking on that? So if the center is just the origin, you don't have any parentheses and numbers. That's only when the center has been moved. Okay. So it's all about direction on this one. Right, left, up or down, positive, negative, x, y.
What did they say?
So what direction is it going? Positive x direction. So positive x to the first. That's always the first power letter. Everybody catching me on that, right? It's important to know not the second, but the first. So which one has positive x first? That does, and that does. That does. Those two. So it's either A or C. It's not this one, not that one, right? Because they have positive y to the first. That's wrong. So it's A or C. Which one? Plug in the point. I don't know. So plug in x is 25, y is 1. Y is 1. X is 25. Yeah, that works, huh? So A it is. It's not C. Good? All right, so now they're giving me some information. They're telling me at the focus and the vertex, and they want me to find the equations. Now we're working backwards on these. How's that going to work? So let me give you some information which I haven't really given you so far. So it's helpful to draw a little picture. Vertex is fancy word for center. Vertex means center. So this one's centered at the origin, 0, 0. Vertex, center, whatever, 0, 0. Focus. What's the focus? Satellite dishes, right? On people's houses. Satellite dish on people's houses. Have you ever seen the way the satellite dishes are? If you look at them, they have a little spokes that are holding something right there, right? That satellite dishes on houses are parabolic shaped. That curvature inside the satellite dish is parabola shape. It's exactly parabola. There's different kind of curves. You know, as you're moving into pre-calc and moving on into calc, you want to think that not all curvature is the same. You know what I mean, right? There's different rates of bending. For example, if I'm driving my car and I'm going around a corner, I can turn, I can hold the wheel at a certain angle so that my curvature will eventually make a circle right unto itself. Or I can hold the wheel so it makes a spiral and comes out and out and out. There's different bendings on the curve, aren't there? Well, so there's all different kind of curves in math. There's different rates of curving. So with that in mind, when we talk about parabolic curvature, you know, this U-shaped stuff we're doing, it's exactly the curvature in a satellite dish. It's also exactly the curvature when you throw anything, right? So if I throw to Sky, you ready? I throw my pen to Sky. That arc that it went through, that's exactly a parabola. That kind of curvature. Thank you. So it's exactly a parabola. So they use parabola equations all the time in the military when they want to calculate artillery, right? If they're firing artillery, they want to know how far it's going to go and height and all that kind of stuff. Or if you throw a baseball or hit a golf ball or anything like that, that's all parabolic arcs. So I'm just giving you the real life use of parabolas here. And the other one would be like satellite dishes, as I was saying. Let's get back to the satellite dish example. So when you have a satellite dish, the curvature is parabolic, and a parabola has what's called a focus point. That's where they hold the receiver on a satellite dish. Why? Because here's what happens. The satellite up in space ships down the radio signals, right? And they come on down, and they hit the parabola, and the bending on the edges of the parabola are curved just perfect to bounce everything, aim everything right at the focus, hence the name, focus. It focuses. All the beams that come in, they bounce right there to the focus. Wherever they hit, the bending bounces them right there to the focus point. That's why that receiver's being held right there. Everything bounces right to that focus point. It's focused on that point. So, and engineers calculate where that focus point is based on the curvature of the parabola. That's what we're going to do as well, is find those equations right now. That's how a flashlight works. That's how your headlights work on your car. They put the little beam in a flashlight or headlights right at the focal point, and it just works backwards. The little light shines backwards on the mirrored parabolic surface inside the headlight, and then that shines it back out. So it's like putting a light right here and shining the light out, and they bounce straight back out because the curvature is perfect for that. That's where they're used. So we got to calculate that focus point. How do we find that focal point? So that's what the A is in the formula. So when I give you that formula, that A is telling you where the focus point is. So anyway, let's draw this first off. They're saying the focus is at negative 3, 0. 1, 2, 3. Boom, right there. Negative 3. So parabolas always, hear this, parabolas always go towards their focal point. Towards their focal point. So if I know the center is here at 0, 0, and here's the focus point, they told me, minus 3, 0, center's at 0, 0, then I know which way this parabola goes. Which way does it go? Up, down, right, or left? Left. Because the focus point is always inside the parabola. So this one must go left. Okay, so what does that mean about, so which, first thing is you just draw that to, they're not asking for a picture here, but I think the picture will really help you. I think it's the easiest way to get things going. So now what would the basic equation be? I mean, would it be y squared is 4ax, or would it be x squared is 4ay?
Y squared equals negative.
Yeah, which direction's it going? Minus x, so that's the first power letter. Minus x, so it's this one with a negative. You with me? Because x is the first power. So let me write that. So as soon as we see, oh, it's going in the negative x direction, because we saw the focal point was left, then it's, y squared equals negative 4ax to the first power. First power letter tells the direction. And the focus point also tells the direction. Okay, so now what's a? You know what a is? It's the 3. It's distance to the focus. That's what that A represents in all those formulas. So it's how far. We've already got, you might think, well, is it negative 3? We've already got the negative. I mean, you're right. I mean, it's negative 3. That's why there's a negative in the front. You just need one negative. What's that?
The distance is always positive, right?
Yeah, it's whichever way you want to call that. Yeah, you're right. You're right. So negative 12x. Where's that one there? Say. Does that make sense?
So we take the opposite.
Yeah, you don't need to be, let me help you with that. Let me tell you what you don't have to stress out about. You don't have to stress out about, oh, is it negative 4 and then is it, just know, in the end, if the thing's going left, it's going to be negative. In the end, whether you say that negative's on the 4 or you say that negative's on the 3, there's only one negative, wherever you want to put it. It's left. So it's got to be negative in the end.
Because the
Yeah.
is just positive.
Yeah, you could say distance is always positive. You want to say it that way. Whatever. In the end, it's got to be negative because it's going left. So that'll always be the case. Left is negative, right is positive. Up is positive, down is negative. That'll always be the case. Good on that? Makes sense? Okay, so,
Already graphed it.
yeah, so I already graphed it. Yeah, I got the graph there. So let me tell you about the lattice rectum points. They're double the distance from the focal point at that depth. Enough said? No. Let me be more clear. So in other words, it's this point and it's this point. These are called the Latus Rectum points. Right there. And what they are at the focal depth, meaning they're at this level. They're at the level the focus is at the focal depth, twice. They're 2a. They're 2a, twice focus distance. So in other words, this is up, bless you, up 6 and down 6. It's double the 3. Does that make sense? So this is the point. Up here, this is the point. Back 3, up 6. This is the point. Back 3, down 6. The lattice rectum points are always out at the focal depth, double whatever the focus was. Negative 3, 6, and negative 3 minus 6. Where'd I get the 6? Double the 3. Is that making sense? So, for example, if you had a focus going up, say it was up at, 4 or whatever, then the lattice rectum would be here and here. They'd be at the level of the focus, and this would be over 8 and back 8, double whatever the focus number is. Is that making sense? So there it is. So type that in. That should work for you. So, and I already got the graph. I'm going to move on. Okay, so the focus is 0, 6, and the directrix line is there. So it's always helpful to graph. It really is. So let's start graphing. The focus is over 0, up 6. 1, 2, 3, 4, 5, 6. So there is the focus point. The directrix line is y equals negative 6. So first off, let's put that's a line going through the y-axis at negative 6. 1, 2, 3, 4, 5, 6. So negative 6 right here. There's the directrix. Directrix line is y equals negative 6. Now, what is that thing? That thing, the center is always, it's always in the middle, exactly in the middle of the focus and the directrix line. The focus point and the directrix line. So in other words, the line, let me go back over here. Let me show it on the last graph. The line on this one would have been back here, 3 units back, because this is 3 units that way. Does that make sense? The directrix line is always behind the parabola. So on this graph, it'd be right here. Right? It's always behind the parabola. The focus point is inside the parabola. The directrix line is behind the parabola. Same distance as the focus line, just behind it instead of in front of it. Right here, it'd be right here. Behind it, focus is inside of it. That makes sense? Directrix line is always behind the parabola. Same distance as the focus. So if they tell me, okay, here's the directrix line. This is behind it. The focus is inside of it. So which way is this thing going? And where is it? If this is 6 this way and this is 6 that way, center is right in the middle of those two, so it must be right at the origin. And it must be going up. See how I know that? That way the directrix line is behind it. This is right in the middle, right? 6, 6. Right in the middle. The center is always right in the middle of the directrix line and the focus point. Going towards the focus. Directrix line is behind it. Kind of directing the parabola from the back. Does that make sense? Is that all good? Erica, you good?
Yeah.
Question? All good? Question I can answer? Is that all making sense? Okay, so there's the picture. Directrix line is always behind the parabola. So for example, what if I had a parabola like going to the right? Where would the directrix line be? Be over here. And the focus would be in there. Same distance. The center's in the middle of them. That making sense? It's always behind. Okay, so now, what do they want me to answer? Oh, they want the equation. So can you write that equation? Let me give you a second to write that equation. Figure out which one's right, A, B, C, or D. It's all about the direction. So going up, down, right, or left? Positive y, up. Positive y to the first. So that's going to be x squared is positive 4ay. Is the basic format of that parabolic equation. Good. So it's not these two. It's x squared equals positive 4ay. The first power letter tells direction up, positive y. So which of those two is, oh, positive? It's a. Huh, I don't need to mess around anymore. It's a. And the a is 6. Remember, the a is the distance to the focus. If a is 6, sure enough, 4 times 6, 24. That's right. We good? I'll move on. You're okay?
More parts.
What's that?
There's 2 parts.
Oh, it's probably lattice. Oh, find the 2 points. Oh, yeah, let's find the lattice rectum. Go ahead, find the lattice rectum points. Remember, they're at the focal depth, or height, as the case may be. At the focal level, double the distance. So it's double 6, going to be 12, right? So it's going to be here and here. They're always at the level with the focus, but they're double. So this would be 12 this way and back 12 that way. Double the focal, right? So this would be over 12 up 6, back 12 up 6. We good? For the 2 lattice rectum? So he's double the focus. So if it's 6 to the focus, it's 12 to the lattice rectum. They're just telling you how wide the thing opens. It opens up twice as wide as it is to the focus. That's what it's telling you. So you know whether it opens up real skinny or wide or super wide, you know exactly how wide it opens. Double. Parabolas are always, that's how their curvature is, double the focus distance at that focal level. They all teach a little bit of a different lesson. Okay, so let's try this one. Vertex is 0, 0. What's vertex mean? Center. So the center is 0, 0. Axis of symmetry. Now, you know what an axis of symmetry is. We've done some axes of symmetry. That symmetry means line through the middle. Huh. An axis of symmetry is a line through the middle of the shape. So if you have a parabola like this, it would be this line. If you have a parabola like this, it would be that line. Does that make sense? The line that spears through the middle of the parabola. Because that's the line the graph is the same as on both sides of. The same as above and below, right? It's the line of sameness, the line of symmetry. So, okay, they're saying the axis of symmetry is the x-axis. This is the axis of symmetry. So what does that mean? That it either goes like this or it goes like that. You with me? It doesn't go up down because then the y-axis would be going through its middle. And they're saying the x-axis is its symmetry line, the line that spears through the middle. So it's either right or left. How do we know which one? Well, they gave me a point. Over 3, up 4. So this point on the parabola, 3, 4, so it must be going to the right, huh? Not to the left. Does that make sense? So there's the general look. Can you write the general equation now? You tell which one it is? So this is positive x direction. Which one has positive x to the first power? Only C. We're done. I don't even need to mess around with the numbers. That's the only one with positive x. This one has negative x. This one has y to the first. The only one with positive x to the first power is C. Good? Bless you. What else do they want? Find the 2 points. Oh, wait, is this the same one?
Yeah,
Oh, they want the lattice rectum. Oh, okay, I better find that. Okay, so yeah, no, this is a little more tricky. I better finish this up with you guys, yeah. Okay, so we got the equation. It's y squared is 16/3 x. How are we going to find the lattice rectum points?
Where the focus is at.
Yeah, we got to find the focus. Where's the focus?
Get it through. You have to grab. Set.
What do you think? Okay, you guys tracking with me on the question? Am I losing you? Am I still coming in clear here? Trying to find lattice rectum. which means we need to find focus because Latus Rectum are just double focus, right? So we got to find focus. How do we find focus? Got to use the setup. What's the setup? Positive 4ax. You got to find a. Remember, a is the focus. Well, how do you do that? That means you got to rewrite 16/3 so it looks like that without really changing it, so you know what a is. Did that make sense? You got to do a little plastic surgery. You got to make it look different, remove the wrinkles, make that thing look different so you can tell what a is. We do a lot of that in math. That's why I use weird words like plastic surgery, to make you realize we're just changing the look so that we can tell what a is, right? I mean, I'm not going to change what it actually is. 16/3, I got to make this 16/3 still, but it's got to look different. So 4 times what is really still just 16/3? 4/3, right? It's 4 over 1, would be 16/3. How we doing? Isn't 4 over 1 times 4 over 3 16/3?
Yeah.
Isn't this just a different look for 16/3? That's still 16/3. I haven't really changed anything. I've just removed the wrinkles, right? It's the same person. That's still 16/3. It just has a different look. Why would I give it a different look? Because I need to be able to see what a is. They're saying if you put a 4 and then whatever's in the middle and then x, that thing in the middle will be a, will be where your focus is. So I've got to make my thing have their look so that I can tell what a is. Do you get that game? We play that game so much in math and science. Do you see that game we're playing? We have to give something a certain look so we can identify a certain piece of a formula. That's what we do all the time. Give it a certain look without changing the actual value. So 16/3, I had to rewrite it as 4 times something times x and still be 16/3. So it's 4 times 4/3 times x. So the a must be 4/3. So the focus is at 4/3. So the focus is at 4/3 because that's the a. We good so far? So where's that? It's like 1 1/3. So in other words, it's somewhere like about here. 4/3 is just a little past 1. But we don't have to be exact on the graph. But I'm just getting a ballpark feel. Everybody with me? It's always inside. It's inside the parabola for sure. That's how I know it's to the right, because it's got to be inside. 4/3, a little more than once, but they're okay. So great. So what am I trying to find? Latus rectum. So where's the latus rectum then? Well, it's at that depth, and it's here, and it's double the 4/3. What's double 4/3?
8 and 6.
8/3. Oh no, you just did 2 times 4/3 is just 2 over 1.
Yeah.
So just double the top, right? 8/3. So that means this is up 8/3 and down 8/3. So that means the answer is it's over 4/3 up 8/3 and it's over 4/3 down 8/3. That's the 2 latus rectum points. You guys good with that? That makes sense on that? So again, I had to rewrite the equation, had to identify the a, that's the focus. When I found the focus, then it's always double that to the latus rectum. So over 4/3, up 8/3, over 4/3, down 8/3 are the 2 latus rectum points. Had nothing to do with that 3/4, huh? Good? All right. Okay, find the equation of the parabola described, find the 2 points that define the latus rectum and graph it. So they're giving me a vertex and a focus. Oh, yeah, now they're moving things. See the vertex, the center, that's the center, is not 0, 0 anymore. So now they're moving things around on us. That always gets a little more, do you really need a graph? Let's get a little picture of this thing. So, back 4, 1, 2, 3, 4, up 1. Right there's the center, the center or the vertex, whatever you want to call it. Same thing. Where's the focus? Back 5 up 1. So here's the focus. There's the center, there's the focus. That's all they're giving me. It's not much information, is it? There's the center, there's the focus of that parabola. Good so far? Which way does that thing go? Up, down, right, or left?
Left.
It's got to go left because the focus is always inside the parabola, right? It's got to go left. We know that. So now we do know the basic look of the equation. What direction is it going? Negative x. negative x to the first power. So it's going to be y squared is minus 4x to the first power, is the general look. Except the center, what's the center? Back 4, up 1. Remember what Barbara observed? It's opposite, opposite. When the center is not 0, 0, not the origin, then you got to put the x and the y with parentheses, opposite, opposite. So this will be minus 4a, and instead of x, it'll be x plus 4, opposite of minus 4. Instead of y squared, it'll be y minus 1 squared, opposite of the positive 1. Everybody good with that so far? See how I'm finding that? Now, I don't know what the a is. Oh, actually, I do. What's the a? Am I going too fast? What does a always represent? How far to the focus? Right? How far is it from the center to the focus? 1. And don't worry about the positive, negative. Remember, it's left, so it's negative. Right? So a is 1. So this is just negative 4 times 1. It's just negative 4. So there's our equation. Which one of those does that? Yeah, B. There it is. See how we found all that? That okay? And they want you to find the lattice rectum points again. What are the lattice rectum points? Here and here. They're at the focal depth. Double. So that'd be up 2, down 2. Down 2 from what? From this focal point. What's the coordinates of that focal point? Negative 5, 1. Negative 5, 1. Add 2 to the y coordinate and subtract 2 from the y coordinate. Am I losing you? Is that getting too confusing? Let me write that again more carefully. So remember, you got to take this focal point and you got to go up 2 and down 2 because that's double the 1, right? So it's double how far to the focus. So the easiest thing to do when things are not at 0, 0, it gets a little sticky. The easiest thing to do is just grab the actual focal point, which is negative 5, 1, right? This point here, negative 5, 1. And then go up 2, which means what? Add 2 to the y coordinate, so it'll be negative 5, 3. And subtract 2 from the y coordinate, which will be negative 5, negative 1.
And then the directive is
And this is
x equals
negative 5, 3. We good on those two lattice rectum, Erica?
I thought A equals the focus point.
A equals how far to the focus point. Good question, good distinction. A is how far. It's not the point itself. It's how far from the center to the focus point. See, now it's more tricky now that we're moving them around. Yeah, A is the jump from the center to the focus point. So A is just 1. So these are the two lattice rectum points. And what's the last thing? They want the directrix too?
Oh, but we're out
But
of
it'll
time,
just
Mr.
be,
Mayor.
it'll be x equal negative 3 then.
It'll be x equals negative 3. Good job. Barbara's got it. We're done. All right.